Hi students, we are going to discuss about ray optics. Ray optics, numericals. Ray optics, numericals. Now, go for the numerical. A convergent numerical. Numerical. A convergent beam of light, a convergent beam of light, a convergent beam of light passes through a diverging lens passing through a diverging lens of focal length of focal length 0.2 meters and comes to focus at a distance of at a distance of 0.3 meters behind the lens. Find the position of the point at which the beam would converge the beam would converge in the absence AB SENCE in the absence of the lens. Dear students, once again I am repeating the question. Listen carefully. A converging beam of light passes through a diverging lens of focal length 0.2 meters and comes to focus at a distance of 0.3 meters behind the lens. Find the position of the point at which the beam would converge in the absence of the lens. This is the question. First read the question twice and write the given data. Now, given here F is equal minus 0.2 meters and V is equal plus 0.3 meters. From the lens equation, from the lens equation, one by F is equal to 1 by V minus 1 by U. Therefore, 1 by U is equal to 1 by V minus 1 by F. That is equal to 1 by 0.3 minus 1 by minus 0.2. That is equal to how much? 25 by 3. This is 1 by U. Okay? That means 1 by U is equal to plus 25 by 3. Therefore, U is equal to 3 by 25. That is equal to how much? 0.12 meters. That means in the absence of lens, the beam would coverage at a distance of 0.12 meters to the right of the concave lens. So like that we have to solve the numerical. Dear students, this is also important numerical. I think this came in the CBSE T010. So please practice this such type of the numericals. Now go for some important formulas. Focal length, focal length f of a combination of two lengths of focal length. Focal length f1 and f2 separated by a distance d is given by 1 by f is equal to 1 by f1 plus 1 by f2 minus d by f1 f2 formula. Once again read this one. Focal length f of a combination of two lengths of focal length f1 and f2 separated by a distance d is given by, what is the formula? 1 by f is equal to 1 by f1 plus 1 by f2 minus d by f1 f2. Now see, focal length f of a combination of two lengths of focal length f1 and f2. If the lengths if the lengths are in contact, that means d is equal to 0. That means the distance between the two lengths is 0. In this case, 1 by f is equal to 1 by f1 plus 1 by f2. Okay? Please remember this point. That means take two convex lens. These are, its focal length is f1, its focal length is f2. The distance between them is d. The distance between them is d. In this case, what is the combination of focal length? 1 by f is equal to 1 by f1 plus 1 by f2 minus d by f1 f2. Okay, now take two convex lens. Take two convex lens. Its focal length f1, its focal length f2. In this case, what is the formula? 1 by f is equal to 1 by f1 plus 1 by f2. Okay, that means previously I thought in the sentence formation, at the same time now I thought in the diagram formation. Please observe carefully. Now, for combination of lens, for combination of lens in contact, power comma, therefore P is equal, what is the formula? P1 plus P2, that is equal, what is the meaning for that one? The meaning is algebraic sum of powers of individual lens. Okay, this is the one of the concept. Now go for next one. Now for combination of two lens separated by a distance small d, therefore what is the power formula? The power P is equal P1 plus P2 minus D into P1 P2. This is the formula. What is the meaning for that one? Take two convex lens. Its power is P1, its power is P2. Now, the distance between them, D is equal to 0. In this case, what is the power? P is equal to P1 plus P2 formula. At the same time, now I took a convex lens. I took a convex lens here. It is P1, it is P2. The distance between them is equal D. In this case, what is the power? P is equal P1 plus P2 minus D into P1 into P2. Okay, once again observe carefully. Take two convex lens, power P1 and P2. The distance between them is 0. In that case, the power P is equal to P1 plus P2. If the distance between them is equal to D and the power of one of the convex lens or concave lens, whatever it may be, its power is equal to P1 and also its power is P2. In that case, the power is equal or the resultant power is equal or the resultant power of the combination is equal to P is equal P1 plus P2 minus D into P1 plus P2. Now, magnification. Magnification of combination. Combination of lens. Small m is equal m1 into m2 into m3 into and so on. Next point, f1 comma f2 comma f and d are in meter. P is in diopter. Next, m1 comma m2 comma m3 and so on m. What is this one? Magnifications of lens or magnification of lens. M have no units. Okay, so these are the important points we have to remember. Now we are going to discuss numericals on this basis.